Hello, great to see you. Hope you're all enjoying isolation. Welcome to today's video, which is parallel vectors. If you haven't yet seen my previous video about vector representation, then that will be a useful video for you to watch before you have a watch of this one, because this video uses some of the information from that one. We're going to start off today thinking about what is the same and what's different about the vectors shown in this diagram. There are multiple different vectors there. I'm going to be looking at which of these statements are true, and this is going to be the main thing that we discuss, that I talk about today. We're going to start off looking at this statement: all of the vectors are parallel. It's useful to know what to discuss for a second what parallel means. Parallel is when two lines go in exactly the same direction, so that the lines, if you extend them in either direction, they will never cross each other. And each of these lines, you can see, does exactly that. What makes a line parallel to another line is, you can see, because of the squares behind, this point here to this point here is one right, two down. This point here is one right, two down to this point here. This one is one right, two down to this point, one right, two down, one right, two down, and it's the same. You can pick any point on any of these lines and it's the same thing. You can go one right and two down from any point on the line to get to any other point on that line. Therefore, these vectors are parallel. If the vectors are parallel, they are always equal. Now, for a vector to be equal to another vector, the vectors have to have the same magnitude, which means length. The length of the vector needs to be the same. The magnitude of this vector goes from here to here, the length of that line. And we could calculate that using Pythagoras theory, but that's for another time. Instead, let's just think about the fact that this line goes two right, four down, as does this one, as does this one, but the lines S and M do not. The vectors S and M are therefore definitely not equal to P, Q and R, because they are of different lengths. Vectors being the same length, however, does not always mean that the vector is equal. Vectors P, Q and R are all equal. Well, they're not. Vectors P and Q are equal. They have the same length, but they also have the same direction. Whereas R has the same length as P and Q, but not the same direction. It goes in the opposite direction. Therefore, vectors P and Q are equal, but vector R is not equal to it. Let's think about what happens if we multiply our vectors by a number. And the number we multiply a vector by is called a scalar. So this vector is equal to a scalar multiplied by this vector. Now, is that true or not? Well, it is true that S is twice as long as R. However, S goes in the opposite direction to R. Therefore, S would not equal 2R, S would equal minus 2R. It's worth noting that if we want to double the length R, do 2 times R, we could go 4 up, then 2 left, but then 4 up from there and 2 left from there would get us doing R twice. So if we multiply a vector by a number, it's the same as doing that vector, doing the motion that vector suggests twice. So from here to here, and then continuing from that point here to up here. So when we think about the vector 2q, 2q is to go right 2, then down 4. The vector 2 minus 4. 2q then would be to do that twice. 2 right, down 4. 2 right, down 4. Which means in total we have gone 4 right and down 8. So what we've done essentially is we've multiplied each part of our vector, each component of our vector as they're called, by our scalar. 2 times 2 gives us 4, and 2 times minus 4 gives us minus 8. Let's have a think about these statements. If you multiply vector p by minus 1, this gives vector q. Is that true? Well, no, it's not, because we already talked about how vector p and q are equal. So vector p equals vector q. But what happens if we do multiply vector p by minus 1? Our vector p, you can see, is 2 to the right and 4 down. So our vector p, and when you write vectors, because you don't have bold font, you should always underline a letter that represents a vector. Our vector p is 2 minus 4. If we multiply that vector by minus 1, then what we end up with is the vector minus 2, 4. Okay? And if we look at these diagrams, the vector p and q, obviously then that doesn't work, but the vector r, if we follow that vector minus 2, 4, goes 2 to the left, 2 to the left, then 4 up, which is exactly right. So therefore what we could say is, because r equals minus 2, 4, we could say p times minus 1 equals r. Okay? And therefore it makes sense that this next statement is therefore true. R equals minus p, because p times minus 1 is minus p. Minus p therefore does equal r. Thanks for watching, guys. I'm just going to leave you with this last final task. See if you can decide whether these statements are true or false now, based on the things that we have discussed. Feel free to subscribe to see any future maths videos that are produced. If you are a member of my class, look out for a special video that I'm going to upload on Friday to do with bow ties. Enjoy yourselves, stay safe, bye for now.